Hello everyone. Here in this video we are going to discuss two different types of forces. One is the conservative force, another is the non-conservative force. So go through the video very carefully, and if there is any doubt then you can post me the doubts. So first of all we are going to discuss here conservative force. As the statement, a conservative force is said to be a force if the work done by the force in moving a body between 2 points does not depend on the path through which the body is moved. It means, suppose we consider a body here, let this be the body, which is kept at a point A, and we have to take this body to the point B through any possible path. Let this be the path, one of the path. Let this be another path. Let this be another path. So there are different paths through which the body is moved. Okay. So out of these four paths, as you can see here, work is done by the force. The force which is moving the body from point A to point B, work is done. But if we find that the work done along when the body is moved along the path 1 is same as that when the body is moved along part 2, that of part 3 as well as a part 4. You can see here all the work done is same. Then the force which is used to move the body from point A to point B is known as conservative force. So I hope this is very clear to you. Whenever we move a body from one point to another, obviously we need some force. But the work done by the force, if it doesn't depend on the path chosen by us to move the body from one point to the other point, if it doesn't depend on the work done, doesn't depend on the path, if the work done doesn't depend on the path, then the corresponding force is known as conservative force. Okay. Now let us take an example of gravitational force, because gravitational force, then electrostatic force, these are the examples of conservative force. So the examples we can write here. One is gravitational force, and another is electrostatic force. So these are the examples of conservative force. Now let us discuss it and explain it a little bit in brief, how we can consider this to be a conservative force. Suppose we first consider the work done in a gravitational field. That is, suppose we consider a coordinate system. Let this be the x-axis, and we have y-axis also here. And suppose at the origin a body is placed. Let the mass of the body be given by m, and you have another body which has to be taken from point A to point B through any possible path. Let this be the path through which the body is moved. Okay. The mass of the body is small m. The position vector of the point A is given by RA, and that of point B is given by RB. I think you remember what is position vector. So, suppose at a point here where the mass small m is shown, it has to be moved from point A to point B by the gravitational force. Now gravitational force is acting in this direction. Let it be given by F, and it is an attractive force between two masses, capital M and small m. We are moving the small m mass under the effect of the gravitational force given by capital M. So let dr be the small distance by which it is moved. So the small work done small work done to move the mass m, small m, by dr, the small distance dr. So the small work done is given by dw, and accordingly we know the formula for work done, force dot displacement. Okay. Now this is the work done, small work done to move the body of mass small m by a small distance dr. Now what we want is the expression for the total work done to move the body of mass small m from point A to point B. What we will do is we will simply integrate it. So therefore, total work done. This is the work done to move the body of mass m from point A to B. Okay. So this work done, let this work done be given by WAB. So it is the integration of the small work done, that is F dot dr, and the limits are from point A to point B. Now if we solve it, we will get a result like G, that is the gravitational constant mm, into 1 by Ra. The derivation is not included in your syllabus, so I am directly putting the values. In class 12 you can understand what exactly and how exactly it comes. Now look at the equation here. We have a formula for the work done, and we have earlier mentioned that the gravitational force is a conservative force. Now let us see how this force is conservative. Now when the body is moved from point A to point B, the formula for work done is given by Gmm 1 by Ra, where Ra is the magnitude of the position vector A and Rb is the magnitude of the position vector of B. So suppose you now change the path. Let's say you move the body of mass small m along this path as I am drawing it now, or maybe along this path which is shown here. Okay. Now in both the paths, as you can see, the value of Ra and Rb remains the same. That means the equation here, which is shown by Gmm 1 by Ra minus 1 by Rb, doesn't change if we even change the path. So that means the work done remains same. So the work done by the gravitational force to move a body from one point A to another point B doesn't depend on the path through which the body is moved. So that's why gravitational force is called a conservative force. I hope this is very clear to you. You need to understand one more thing. The same way we can show that electrostatic force is also a conservative force. Now there is another way of representing conservative force. So let us see how it can be done. See, what we can do it, we'll take the same example and we'll continue here. Suppose we consider a coordinate system, that is, here we consider the x-axis, and again we consider another axis, that is the y-axis. Okay, now suppose a body is moved from point A, this is the origin is occupied by mass capital F. Now a body is moved from point A to another point B, and then again it is moved back to the point A. Let the path be given by AXB initially and then from BYA. So you can see the path. Now if the total work done, let us find the total work done, and what we can see here, this is the gravitational force which is acting here. So this is Ra, the position vector of the point A, and this is the position vector of the point B, Rb. So suppose we need to find the total work done about the cyclic process, that is the total work done to move the body of mass m over the cyclic path. Now total work done we need to find. So the total work done here will be work done from AXB along the path AXB plus the work done from BYA. So the formula for AXB will be obviously be GMM as given in the earlier equation, 1 by RA minus 1 by RB. And the another one GMM, the second path BYA, it will be 1 by RB initially minus 1 by RA, obviously because now it is starting from B to A. So they will cancel out, as you can see the negative terms they cancel out and the work done is 0. So we know that gravitational force is a conservative force and the total work done is 0 when the body is moved over a cyclic path. So there is another definition that we can consider for conservative force, and that definition is written earlier as you can see here. In this definition we can say that a force is conservative, a force is said to be conservative if the work done by the force in moving a body along a closed path is 0. So I hope this is very clear to you, the conservative force. Now let us move to the non-conservative force. See here. This is the definition for non-conservative force. Obviously, a force is said to be non-conservative if the work done by the force in moving a body between 2 points depends on the, this is very important, it depends on the path through which the body is moved. Earlier in conservative force, it doesn't depend on the path, the work done doesn't depend on the path through which the body is moved, but in non-conservative force it depends on the path. Also, when the body is moved over a cyclic path, then the total work done will never be 0. That is, a force is said to be non-conservative if the work done by the force in moving a body along a closed path, this is the closed path, is non-zero. And the simple example for the same is the frictional force, or simply we can write friction. Friction is a non-conservative force because suppose a body A is at point A and this is point B. Now, when it is moved along different paths, the surface is different. The curvature in the surface or the roughness in the surface will be different in different positions, and obviously the work done now will be different. Let it be given by W1, W2, W3 or W4. So obviously when the work done is non-zero, then the force is non-conservative. Or if we take the body over a closed path, that is we move it from A to B and then again from B to A, the work done will be added up in both the cases and it will never be 0. So the total work done will not cancel each other. So I hope both this non-conservative and conservative forces are very clear to you. But still then, if there is any doubt, you can post me the doubt. So thank you and have a nice day.